All right, so moving on to question 31. So here we're going to be writing a function in factored form. And when we're done, it's going to look something like this. Y equals, we're going to have a number for a, and then we're going to be figuring out what our factors are. And as we do this, I'm just picking random letters. Okay, so the first thing I'm going to start out with are my factors. So one x-intercept is -3, and the factor that got me there was x plus 3. And since it crosses through, x plus 3 is only going to show up once. The other x-intercept at 2 came from the factor x minus 2, and since it bounced, that means it showed up an even amount of times, so I'm going to put a squared there. And the other x-intercept at 5 came from the factor x minus 5, and again, it crosses through, so it's just going to show up once. So right now, just kind of starting my equation, y equals a, and then I'll have an x plus 3, an x minus 2 squared, and an x minus 5. So what I need to do still at this point is to find, my a value. So I'm going to do that by taking the y-intercept, 0, -2, and plugging them in for y and the x's over here. And then when I'm done with that, I'll be able to have enough numbers that I can solve for a. So in for y is going to go -2, and then a, and then I'll put 0 plus 3, 0 minus 2 squared, and 0 minus 5. And then just kind of cleaning up the right side. I'll still have the a, but 0 plus 3 is 3. 0 minus 2 here is -2, and when I square that, I get 4, and 0 minus 5 is -5. And then just carry down the -2 on the other side. Still just cleaning it up. On the right side, I'm going to have a -60 with a, and then to solve for a, I'll just move the -60 over to the left side by dividing. And when you're done, you're going to get a to be 1 over 30. And now we can write the equation. So the equation is going to be y equals a, and then putting my factors back in, x plus 3, x minus 2 squared, and x minus 5. And so if you actually go to your graphing calculator and type this in, you should see a graph that's looking like this. Okay, all right, moving on to the next one. So this is a quadratic, and we're going to be putting it into vertex form. So the base we're going to use for that is y equals a, x minus h squared plus k. So what again I need is all equations have x and y. So what I'm going to do is take my vertex, which is -2, 3, and I'm going to put that in first. So x minus -2 squared plus 3. And just cleaning it up, I'm going to add the opposite on those parentheses. And the last thing I need is a. So what I'm going to do is take another point, and let's see, what's another good point to use? I'm not sure about the y-intercept, but I think this point right here is pretty good. I can tell what that one is. That is -1, 6. And I'm going to put this in for x and for y. So in for y is going to go the 6. And then in for x is going to go -1. And I'm just going to clean up the right side and figure out what a is. So in the parentheses, I get -1 plus 2, that's 1, and 1 squared is 1. And then to clean up the right side still, that's just a times 1 is a. And then to get a alone, I'll subtract the 3, and a is 3. So then I can write my final equation. Y equals 3, and then I'll go back to the rest of vertex formed. So some of your teachers talk to you guys about this pattern and another way of finding a, and that is once you get the vertex, just check out your over 1 up amount. So usually we go over 1 up 1, but this time we're going over 1 up 1, 2, 3, and that a being 3 is all you need to do to get to there. So depending on how you learned, there's 2 different ways to do it. All right, last question, writing the exponential function. So this is the most recent part that we did based on y equals b times g to the x. So I'm going to take my first one and just put y and x in. So notice we've just been putting y and x in and cleaning things up. All right, so 5 equals b times g to the third. And then the second one, I'll put y equals b times g to the 7th. So what I do from here is I rearrange both equations so that b equals everything. So I'm going to move the g to the third to the left side by dividing. So this is now b equals 5 over g to the third. And I'll do the same on the right equation. Just divide by g to the 7th. And so then I have b equals 50 over g to the 7th. So what I do now is, since both equations equals b, we're going to use the substitution method and have these two just equal each other. And then to solve for g, we don't want them in a denominator. I'm going to use cross products to get them out of a denominator. So I'll have 5g7 equals 50g3, and then I'm going to start to isolate the g's. So I always move the g's first, and I'm going to move this g third to the left side by dividing. And then I'm going to move the 5 over to the right side by dividing. So what ends up happening is, on the left side I have g7 over g3, on the right side I have 50 over 5, and then I'm just going to simplify, so I get g to the 4th over 10. And so now to solve for g, I will need to take the 4th root of g. So you can go to your calculator, and I'm just going to press the math, or 4, then press the math button, choose the 5th option, and take the 4th root of 10, and we will round this to the nearest thousands, so 1.778. And now last thing I need to do is find my b. So what I do is I go back to these equations that I had over here, and you can use one of these. Either of these will work, but I tend to go with the one that has the smaller numbers. And to find b now, I'm going to take 5 and divide it by 1.778 to the 3rd power. So this time I'm not going to show the calculator, but I'm just doing 5 divided by 1.778 to the 3rd power. And my b is also a long decimal, so I'll just make it 0.890 is how it would round. So now I can write my equation. Y equals b times g to the x power. And if you go to your graphing calculator and type this in, you should see values that are really close to the original values that we started with. They won't be quite exact, but that's just because we rounded these numbers over here. Okay, and that's it. That is those pages for the review.